All right, welcome back, guys and girls. Mr. Martin here, Mr. Martin's Math Corner. We're going to talk about simplifying radicals in this section, 11.1. We're going to simplify some radical expressions using these radical properties, and we're also going to identify some rational and irrational numbers by connecting them to exact and approximate solutions. All right, so first things first, we need to know the parts of a radical. Okay, it's very good for you to know the anatomy of the radical, and this graphic right here really gives you a in-depth look at what is going on. So let's start with this A. Anytime you got something to the left of the radical sign, that's going to be your coefficient. Remember, any kind of coefficient means we are multiplying to what's next to it. Okay, and then you got this B right here. Okay, so the little number that's on the outside of the radical, we call that the index, and this tells us what root we are working with. And if you do not see a value, this is highly important. I might underline it. It is assumed to be a 2. Okay, so if you see something like this, the reason we call that square root is because there is a 2 there. We just don't write the 2. That is the default. Okay, now you might have a third root, which would be a cube root, or a fourth root, and so on. Okay, then we got the radicand, one of the coolest words in the book. And this is the value that you're taking the root of. Okay, so very important to understand these parts of the radical. All right, let's scroll down. We got tons of generic definitions here. These are our properties, right? And these just describe different things that we can do when simplifying radicals. And then I gave some examples here on the right. So I want you to just pause the video here. You guys can take the time to look at it. Like if you looked at this one, this is saying some coefficient of x. We have the nth root of a plus some coefficient y with the nth root of a. Looks like they have the same radical, same index. Okay, then that means you can add the x and the y, right? This had to be a 2 and an 8, 2 and an 8. They only added the 5 and the 7. So boom, you see how that works. I just explained it. Follow that along with all the other examples. It's kind of fun to dive in yourself and see if you get that understanding. Okay. All right, so let's go ahead and jump right into it. My favorite part. Boom. All right, so example 1, it says simplifying by dividing by a perfect square. So it probably would have helped if I scroll down a little bit more, because this is something that you should have in your tool belt. And I put a little note down here that says, please make sure you know all your perfect squares, at least 1 through 12. Like 1 squared equals 1, 2 squared is 4, 3 squared is 9. 4 squared, 16, right? If you know all the way up to 12, you're going to have a much easier time doing these. But if you don't, I'm going to show you another way to do it if you can't remember these numbers. But you also got to know how to divide. Okay, so division is important also. If you struggle with that, please have a calculator handy and get them quick fingers going. All right. So the first one I want to show you is just dividing by a perfect square. So if I got this number 8, I want to ask myself, what is a perfect square that I can divide 8 by? Well, I know 1 is a perfect square. I don't really care about 1. Everything can be divided by 1. My next one up, 2 squared would be 4. Can 8 be divided by 4? It sure can. So let's check if it works out. We got 8 divided by 4, and boom, do we get a whole number? We sure do. Boom, check it off the list. All right, 108. Do we have a perfect square that goes into 108? Well, I believe it can be divided by 36. Yeah, buddy. So 108 divided by 36. 36 is 6 squared, and that gives me 3. So yes, that one will work. Do I have a perfect square that can divide into 20? Yes, we can divide that by 4. Remember, 4 is a perfect square. We get 5, so that one checks out. What about 75? Boom, you guessed it. 25. Divided by 5. Oh, sorry. Whoops. 75 divided by 25. That would help. That gives us 3. Looks like that checks out. 45. Looks like we can do 45 divided by 9. Alright, and that's going to be 5 as well. That checks out. And then 18 can also be divided by 9. Boom. So that gives us 2. So when you are trying to divide by a perfect square, you need to make sure that when you divide by a perfect square, you end up with a whole number. So what we're going to do is we're going to use this property. I'm going to go back here and show you. Okay. This property tells us if we have some product, right, comprised of two factors, a times b, right, we can split them up as the nth root of a times the nth root of b. And you can also go backwards, as you can see in this example here, kind of. All right, we can combine these. That a and b can combine to 20. All right, so let's go ahead and rewrite that. We know that we got our perfect square of 4, so we're going to take the square root of 4 times, what's our whole number that we divided to? Radical 2. So we knew if we did this back, right, radical 4 times radical 2, that would give us radical 8, so we're back where we started, so that is good. But now we want to actually simplify. What is the square root of 4? That is going to be 2. And then we have the radical 2. So 2 times radical 2 gives me 2 radical 2. All right, fairly simple, right? So let's do this one. We got 36 that we know we divided by. That's our radical. So we're going to do radical 36 times. We had that whole number of 3 left out. Radical 6 times radical 3. Radical 36 is going to be 6 times radical 3, and we get 6 radical 3. All right, I'm going to do this one for you, and then I'm going to let you guys pause the video. So this one has a coefficient on the outside, and what we know about that is that it is multiplying. This is a stream of factors. All these factors next to each other all actually multiply. So what we're going to do is we're going to have this negative 4 on the outside. That is multiplying to the radical 45, but we're going to break up that radical 45 as radical 9 times radical 5. Okay, now we can take the radical 9, right? So we got negative 4. Radical 9 is 3, so we're going to do times 3. Then we got times radical 5. And now we just clean everything up, simplify it. Negative 4 times positive 3 is negative 12 times radical 5 is negative 12 radical 5. Boom. All right, so go ahead, pause the video right now. I want you guys to knock out the next 3, or the remaining 3. All right, welcome back. So hopefully you got what I got. This first one up top, I ended up with 5 radical 3. Down below, I had a negative on the outside. Remember, there is a value there. If you don't see it, that is a negative 1. So that's what I put on the outside. And I split it up to radical 4 times radical 5, because we can square root that 4 and make it a 2. All right, and then last but not least, I ended up with 15 radical 2. All right, so if you have a handle on your perfect squares, it's just a little bit about dividing those numbers, breaking them up into 2 different radicals, finding the ones that you can take the square root of evenly, and then applying to the ones that cannot simplify themselves. Like a radical 5, you cannot simplify. It's just radical 5. All right, let's move on to example number 2, simplifying by finding prime factors. Okay, so if you do not have a handle on your perfect squares, we can do what we call finding the prime factors. I've showed you guys this before, and this is where we want to look for what I call pairs. All right, so we got this 72. So I'm going to do this to the side right here. 72, that's going to be 2 and 36. 36 would be 2 and 18. 18 is 2 and 9. And then 9 is 3 and 3. So remember, I have all of these are my prime factors. 2 times 2 times 2 times 3 times 3. So we can rewrite this radical, okay? So I'm going to do 2 times 2 times 2 times 3 times 3. Okay, and then I put my bar up top. So remember, I am trying to find pairs, because remember, a perfect square is something times itself. So you need to have you and yourself, which is you and a twin. So how many twins do I got? Well, I got a 2 and a 2. That's good. Got this 2. There's no other 2 there, so I can't use it. But I do got this 3 and this 3. Okay, so how many pairs of 2s did I find? I found 1 pair of 2s. So that means I'm only taking out 1. Okay, this 2 that we're taking out, remember, because this is 2 times 2, which is 4. Square root of 4 is 2. But we can think of it as I'm taking out, the group is a 2, and I only took out 1 of them, right? If I only took out 1 of them, it would be to the exponent of 1, and 2 to the 1 would give me 2. All right? But I also took out this 3, so I got to do times 3, and then I times my radical, and I times it by whatever is left inside. Here we only have a 2, so that is just our 2. And then we got 2 times 3, which is 6, and then we got radical 2. Boom, pretty easy. Okay. All right, we got a big number here, 245. Let's break that up. All right, 245. My brain is failing me now. Can I divide it by 3? I know I can't divide it by 2. Let's try 3. 245 divided by 3. No. So the smallest we could do is 5. So we're going to do 5, and 5 goes into 120 times. So 40, 49. If I am correct, I am. All right, and then 49 is going to be 7 and 7. So this 245 now becomes the square root of 5 times 7 times 7. All right, looks like we only got one group of 7 times radical 5 is going to equal 7 radical 5. Not too bad. All right, you know what it is. Pause the video. I want you guys to try the next two. All right, welcome back. Hopefully you got what I did. 15 radical 2 for this first one. Remember, if you got that coefficient on the outside, that just multiplies to anything that you took out from the radical that you simplified. And then don't forget your signs always play a major role. So negative 5 times 3 gave me that negative 15, and we got radical 3. Okay, so you can either do the prime factor. Some people like breaking it up. Me personally, I remember my perfect squares really well, and dividing hasn't been too big of an issue for me. When you get into some of the higher numbers, I might slap that into a calculator, like that 245. I probably wouldn't know what perfect square divided into that. So I might fiddle around on the calculator a little bit. So maybe prime factoring was quicker for this one. All right, next up we have multiply and simplify radicals. Okay, and I do want to go back to our chart here. So remember, what this tells us, if we have the same index, okay, then we can multiply the coefficients together, right? Don't forget to multiply the coefficients. And we also need to multiply the radicands. Okay, and there's multiple ways you can go about doing this. You can simplify a radical before you multiply. You can multiply and then simplify the radical. It's really up to you. And you'll see that in a couple of the examples that we do. All right. So the first thing I want to do is I want to set up writing the multiplication of my coefficients. I know I'm going to multiply these regardless. So I'm going to do 4 times 2. Okay. And then we can break down these if we want. So, right, 5 is already a prime number. 15, we can prime factor. That's going to be 3 and 5. Okay, so we know we're multiplying these two, which is this times this and this. So let's go ahead and put that as a radical. So we got 5 times 3 times 5. And we want to ask ourselves, do we have any pairs going on in here? We sure do. We got this 5 and we got this 5. So it looks like we can factor, not factor, but we can simplify a 5 out of this radical. So we're going to do 4 times 2 times 5 times radical 3. Okay, and then if we do our multiplication, 4 times 2 is 8. 8 times 5 is 40. We are left with 40 times radical 3. Okay, let's go ahead and do this one. We got 15 and we also have 10. So 15, that's going to be 3 and 5. 10 is going to be 2 and 5. Alright, so we got our negative 3 times negative 5. And then we have in our radical 3 times 5 times 2 times 5. Do we got some pairs? Just one of them, just these 5s. So now we got negative 3 times negative 5 times 5 times 3 times 2. And now let's just clean this up. Negative 3 times negative 5, positive 15. Positive 15 times positive 5, that's going to give me 75. And then 3 times 2 is 6. So I'm 75, radical 6. So not that much different, just a little extra set of multiplication with the coefficients in there, and breaking down 2 different radicals. Alright, so pause the video here. I think you guys can handle the bottom 2, and then come on back. Alright, great job, because I know you hit a home run here. You were learning really well because I taught it really well, and you got that negative 30 radical 30 and also 96 radical 2. So the choice is yours. If you want to multiply and get big numbers to find those perfect squares, you can do so, or you can break down these little tiny numbers and find those pairs. Makes it a fun little game, kind of like a scavenger hunt while you're working. Yeah, so let's get to it. Example number 4. I believe this is my last example. Let me check here. No, we got another one after that. Alright, so add or subtract 2 radicals. Okay, so there is a rule here. Let's go back and take a look. I know you memorized it already because I had you pause and look at that chart. Alright, so we have the addition 1 right here. So this is saying some coefficient of the nth root of a plus some coefficient of the nth root of a. Meaning, if we look at them, what are the same? The nth root of a. Okay, and if you look here in our example, the only reason we were to add these up is because they were both the square root of 8. Okay, so these are basically to be thought of as like terms, right? You remember when we did exponents, you can only add an x squared with an x squared, right? So it's the same thing with these radicals. If the radicands are the same, you can add or subtract the coefficients. So sometimes they will be, sometimes they won't be. Look at number 1. It looks like they will be. We got square root of 12 and square root of 12. So we can add these coefficients. This one's pretty easy, straight up. Negative 3 plus 2, that becomes a negative 1. And then we keep our radicals the same. Boom, that's it. Uh-oh, spaghetti-o, what happened here? Well, here I got 2 radical 2, and here I got 2 radical 8. Well, I can't simplify radical 2, but can we simplify radical 8? We sure can. So let's take a look at that. So we're going to drop this down, 2 radical 2. Okay, this is going to turn into 2. We know a perfect square 4 goes into 8, so I'm going to do 2 times radical 4 times radical 2. This now becomes 2 radical 2 plus 2 times radical 2. And then we get 2 radical 2. 2 times 2 is 4 plus 4 radical 2. Boom. Now we have what we need to be able to add those coefficients. So let's go ahead and add those up. We got that 2 and that 4. That's going to give me 6. We keep that radical 2. Okay, so sometimes it takes a little bit of simplifying in order for you to be able to add those coefficients. All right, I'm going to do one more with you. Radical 6, can we break that down? No, there is no perfect square that goes in there. 54, we know that 9 goes in there, so let's go ahead and do that. So we got 2 radical 6 plus 3 times radical 9 times radical 6. Oh, and if you look, we already know we're in the right place to be. Okay, so radical 6 plus 3, this is going to be times 3 times radical 6. And then we get 2 radical 6. 3 times 3 is going to be 9 radical 6. We're adding these two numbers up. Boom, that gives us 11 radical 6. All right, pause the video, come back. You do that last one. All right, good job. So we broke it down, that radical 4, we got that radical 3 to match. Bing, bang, boom. And we ended up with negative 9 times radical 3, one of my favorite radicals. All right, now we are on to our last example. Oh, what? We got variables. Boo. Actually, not boo. These are actually really easy. Not that hard at all. All right, so you might have a little bit of note side right here. Remember, it's really easy to find our perfect squares with numbers, right? Okay, it's the same thing with our variables. We can think of our variables as perfect squares. Okay, if I have x squared, that is a perfect square because that is x times itself. If I have x to the 4th, that too is also a perfect square because that's x squared times x squared. Okay, and so on. So that's one way that you can look at the variables. I have like a different approach. I like to prime factor the variables out because it's really easy to just think of how many pairs of this letter am I taking out. And remember, if we're dealing only with square roots, that's the reason why we are looking for pairs. All right, so let's break this down. So square root of 144, that looks like a magic number to me, so I'm just going to put that by itself, times m squared and n squared. Well, square root of 144, this is actually a perfect square, which is 12 times 12. Okay, but now here I want to figure out how many pairs. Okay, so if we prime factored this out, this would be m times n times n. So I'd have one set of m, and I'd have one set of n. And that's it. This is fully simplified. All right, so let's do the 24. Okay, so we can break this down into numbers, or we can do the prime factoring if you like it. Okay. So is there a perfect square that goes into 24? Yes. That would be 4. So we got the square root of 4 times the square root of 6. And then I also have the square root of u squared, and then times the square root of v to the 4th. So I'm just breaking each one of these down. Square root of 4 is 2 times, we got the square root of 6. Okay, square root of u squared, right? If I have u times u, I could take out 1u. And then if I have 4, remember that's how many? V times v times v times v. I'm taking out 2 groups of v's. So the way we write 2 groups of v's is we actually square it. And we want to put everything before the radical, so we would actually write this down as 2u v squared radical 6. All right, I'm going to do one more, and then I'm going to save the last one for you. 54, that looks like it's going to be 9 and 6, so we could do something like this even. Square root of 9 times square root of 6a cubed b to the 4th. You might even like this a little bit better, so I'm kind of jumping all over the place showing you different ways you can do it. Maybe stick with this one. I like this one. I'm going to put a star next to it. So take out your perfect square. Put everything else under the other one. We know that's going to turn into a 3. Okay, then I want to look at my variables first because I can't simplify that 6. Okay, if I got 3 in my exponent, I'm looking for pairs. Pairs mean 2. So how many groups of 2 can I take out? Well, if I took out 2, right, that's 1 pair, which means, right, that 6 will stay in there. If I took the pair out, I took 2 of these away, I'm left with a 1. And then if I have a 4 here, that means I got 2 pairs. 2 pairs is 4, so I'm taking that whole thing out. And that means I took out 2 pairs, and there is no more B on the inside. Boom, so that's it. Oh, actually, let's rewrite it without that. So we got 3AB squared 6A. Boom. All right, go ahead and pause the video, crank out that last one by yourself, come back and check it. All right, fantastico. I know you got that because I taught you well. And I said that earlier, so I probably overused that. All right, so that is all I have for you guys today. Remember, do the practice, do the mastery check, crank those out. Make sure you get that learning going. If you need help, reach out, ask a friend, family member, teacher, anybody you got. It's been a blast. I'm going to catch you guys on the next one. Peace.